Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 16 in our incredible new tutorial series where you're teaching your Raspberry Pi who's boss. What I'm going to need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee poured over ice, no sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is actually sponsoring this most excellent series of Raspberry Pi lessons. And in these videos, I will be using the most excellent Sunfounder Ultimate Raspberry Pi Kit. They might call it the Vinci or something else now, but if you look down in the description, there is a link to the kit that I'm using. Hopefully most of you guys, now that we're on lesson 16, already have your hardware. But if you don't have your gear yet, look down in the description. There is a link over to Amazon and you can order your equipment. But enough of this shameless advertising. Let's talk about what I am going to teach you today. And what I'm going to teach you is I'm going to show you my solution to the homework assignment that I gave you in lesson number 15. First question is, how many of you were successful? If you were successful, leave a comment down below. I am legend. If you were not successful, leave a comment down below. I folded up like a cheap Walmart lawn chair. Hopefully most of you guys got it, because really this was a pretty straightforward lesson, pretty straightforward homework. What we were doing was just putting together things that we had learned in some of the earlier lessons. I like to do that. How do we learn? We learn by exercising skills. So we learn a new skill, and then what we need to do is we master it, and we master it by doing it more than one time. That's why I try to build homework assignments that utilize things not just from the last lesson, but from lessons that are earlier. But enough of this introductory discussion. Let's jump in and let's look at how I did this assignment. And what the assignment was to create a dimmable LED where you were using the ADC0834 Analog to digital converter to read a number off of a potentiometer and then to use that number to control the brightness of an LED. Okay, let's see how I do that. I always like to start by showing you my studio. Show you that I am keeping my studio neat and clean. You see that? I guess this book is not, that my little notebook is not exactly straight. We need to get that straight. Then down here you can see this is my build area. And what we'll be doing now is we will be going to an overhead view of the build area along with the circuit that I actually used in this, in this solution. So first of all, you can see up there is the schematic, and then here is a live shot of the build. A lot of this is very similar to what we had done last week. We had this breakout board coming from the Raspberry Pi, this Sunfounder breakout board, this T connector coming to the breadboard to make our connections easy. We have the ADC0834 Analog to digital converter here. We have a potentiometer here. We're reading off of the center leg of the potentiometer and we're coming into pin 3 of the A to D converter, and that would be channel 0. And then that was all done last week. What we did this week is I added a 330 ohm current limiting resistor. I connected it to an LED, the long leg of the LED, and then the other leg of the LED is grounded up here to the ground rail. The one thing is I connected this resistor to the GPIO pin 23, and that's pin 23 in the what? Pin 23 in the BCM numbering system. Now, why did we go from the board numbering system to the BCM numbering system in the middle of these lessons? Well, that's when we started using the breakout board, because the breakout board is using the BCM numbering system. So then it's easier for us to use that because the labels then match what our code is. All right, so you guys hopefully already got that built. And so I will come over here to the code view. If I can find it. Okay, there it is. And then I'll go ahead and scoot this out of the way a little bit so you can see what we'll be looking at in a minute. We'll be looking at the potentiometer and the LED. But I think we're ready to start coding. The other change we made sort of in the middle of these lessons, we went from Nano, which is a simple text editor, we started using Thony or Thony, whichever way you want to say it. And so what we're going to do is we're going to go ahead and fire up Thony. And then what I'm going to do is I'm going to go ahead and save an empty program and I'll just call it mypotdim.py, mypotdim.py. I am in my Python folder, which is good. I'm in my Python folder and I can get this up here and I will say okay. So I think we are ready to code. What's the first thing we need to do is we need to import our friend, who is our friend Mr. RP lowercase i.gpio, and I will import it as GPIO. You can import it as kitty litter box if you want. It's just GPIO is a little bit easier to type and a little bit more meaningful. We actually had one student, a Mr. Daniel, young man, actually did one entire homework assignment naming his RPI library kitty litter box. And you know what? It worked, but thought that was pretty clever. So we tip our hat to Daniel for that little bit of craziness. Okay, what else do we need? We need to import the library ADC0834. And remember, this library does not come with the Raspberry Pi. And so if you don't have it, you need to go back and look at the last video where we show you how to install that library. Okay. Then also from time import sleep. Why do we do it this way? That way that we don't have to put time.sleep. If I just said import time, I would have to do time.sleep. If I say from time import sleep, then all I have to do is just sleep. Makes things a little bit easier. Now we're going to need a delay time, so I'm going to go ahead and put in DT for delay time, and let's just make that 1/10 of a second, 0.1. Now I'm going to set up my my LED, so I'll give it a red pin for the red LED. And I do believe we said that in the BCM numbering system, that was in fact BCM pin 23 that I had that hooked to. Okay. Then also I'm going to go ahead and set an initial duty cycle of 0. That way when we start with a duty cycle of 0, the LED will be off, if that makes sense. We got that set up. Now we're going to need to do our GPIO.set mode. And what are we going to do? We're going to do a GPIO.BCM, because that red pin is 23, BCM 23, not board 23. Okay, so we got that set up. We've got that set mode done. Now let's go ahead and turn on our analog to digital chip, and we can do that with an ADC0834 set up. That will get that thing fired up and initialized and ready to go. Now we need to set up our output pin, which is that red pin. So we'll do a GPIO set up, not set mode this time, but set up. And what do we want to set up? We want to set up the red pin, and we want to set it up as a GPIO.out like that. That looks good, doesn't it? Okay, and now I need to go ahead and turn on my PWM, because if we're going to make this a dimmable LED, it's going to need PWM. And so what I need to do is I need to go ahead and do a my PWM. I need to create my PWM object. So my PWM is equal to GPIO.PWM. And then what do I want to make a PWM? My red pin, my LED pin, and I need to give it a frequency, and I like to do about 1,000 Hertz, because that makes it so fast there's no way you can even imagine that you're seeing it blink. And now we need to go ahead and we need to start the PWM. So I'll say my PWM dot start. And I will start it with the duty cycle, which is 0. In a 0 duty cycle, it means the LED will start out being off, if that makes sense. Now we're ready to start looping, so we need to do our try and except. So we will try to do the following things, and if we can't, we will jump down to the except, and then what do we want it to be? We want it to be an except out to keyboard interrupt. So that just means that you are going to sit and you're going to loop up in the try part until what? Until it sees Control C. That's the keyboard interrupt, and then it will jump down to the accept. And what do we want to do there? Give me just a second to manage things a little bit here. Get my windows where I need them. Okay, so then we'll come back down here. So what do we want to do on the keyboard interrupt? There's a couple of things. I want to do a mypwm.stop. Okay, I want to stop that PWM, and then I want to do a GPIO.clean up. And then what I want to do, I want to print a GPIO good to go. Now, why do I do that? That way, when I exit the program, I want to see that GPIO good to go. And what that tells me is that I've actually cleaned things up, that I didn't leave in an unexpected way and leave those pins tied up. I hope that makes sense. Now, what do we do in the try part? So we've got the kind of structure, the skeleton done, but what do we actually do here in the meat? Well, we want to loop. So what do? We say while true. When is true, true? True is always true. We're creating an infinite loop. And now what do I want to do? I want to read the value from the potentiometer. Okay, and so how do I do that? I say pot val. Okay, pot val is going to be equal to ADC0834, my analog to digital converter, get result, and then I want to get the result from which channel. If we look over here, I'm connected to pin 1, 2, 3, so the center leg of the potentiometer is connected to pin 3, which we learned last week is channel 0. So if I read from channel 0, I am reading from pin 3. So we got that done. Now I think what we need to do is we need to change this pot val, which is a number between 0 and 255, and we want to change that into a duty cycle, which is a number between 0 and 100. So we need to do a little what? We need to do a little bit of math. We need to do a little bit of math here, so I need to switch off of this. And then I think I can switch over here if you give me just a second. This is the most awkward transition because the RiverCam and the Sketchpad share the same port, so I have to do a little bit more switching to get to this view. But okay, let's think about it. If I read 0 on the potentiometer, that was kind of awkward. Let's see if I read 0 on the potentiometer, what duty cycle do I want? Well, if I read a 0, I want a 0 duty cycle because I want the LED to be off. So if I read 0, I want to apply 0. What's the other extreme? Well, if I read full scale, I will be reading a 255 on the potentiometer. And if I read a 255 on the potentiometer, what duty cycle do I want? Well, I want full on, and that would be what? That would be 100. Okay, so I have 2 points, and if I have 2 points, I can make a what? I can make a line. But if I'm going to do a line, I need to calculate the what? I need to calculate the slope. And so I can do that by saying m is equal to y2 minus y1 over x2 minus x1. I always like to use my parentheses because that's a very good habit. And so y2 is what? It's 100 minus y1, so this is y2, and this is y1. 100 minus what? Minus 0 over x2, which is 255, 255 minus x1, which is 0, and so I am getting 100 over 255 for a slope. Okay, and so my slope is equal to 100 divided by 255. Now, how do I calculate the equation of the line once I have the slope? Well, y minus y1 is equal to m onto x minus x1, and we know most of this stuff. First of all, we know that this is x1 and this is y1, and so both of those are 0, so these terms are going to drop out, and I'm left with y is equal to m, which is 100 over 255 times what? Times x. Okay, and guys, over and over you guys say, oh, I don't need to use the equation of the line, because if I take this and I put it over this and I do this, and you tell me this little way that you do things that's going to work about a third of the time, and it will work. The thing you guys are doing is it will work if there is not a y-intercept. If there's a y-intercept, it won't work. Why not just do the math? How long did this take? I ask you, how long did this take? About 1 minute. Invest a minute in your life to actually do the math and do it right, okay? Now, we're not dealing with y's and x's. We are starting with a what? We're starting with a pot val, so that's like our x, and so that's going to be here 100 divided by 255 times what's our variable? We are using pot val as our x value, and then we're turning it into what? Duty cycle or DC. Now I've got an equation here that I can use in code. It's like I'm not going to make a mistake because I'm going to look at the equation because I did it on paper first. And if there was anything, I wish I could get you guys to think like an engineer and act like an engineer. And even problems I can do in my head, I sit down and I do them on paper, because that way I'm building that skill and I'm going to get it right. I'm not going to make a mistake. So now we can come back over, I believe, to our code view. Is this, where did our code view go? There, I think that is our code view. Take a swig of coffee. I have my equation set up now, so I can come back over here. And what am I going to calculate? I'm going to calculate my duty cycle DC, and that is going to be 100 divided by 255, and then I'm going to multiply that by what? Pot val. And that's that equation that I just came up with. All right. So now when I'm reading a 0, I'm going to apply a 0. When I'm reading a 255, I'm going to apply 100. That's going to go from full off to full brightness. Okay. And let's see. I think maybe it doesn't like to apply 100. I think 99 is as high as you can go. So I can just say, just to be safe, if DC is greater than 99, okay, then make DC equal 99. That just makes sure we don't try to write something more than 100%, and even 100% I think causes problems. So we'll go from 0 to 99, and we make sure that we don't go over 99 with that little thing there. Okay, now what do I need to do? Now I need to apply that duty cycle to the LED. How do I do that? It's really simple. My PWM.what.change duty cycle. Okay, change duty cycle, and I want to change it to what? To DC, which we just calculated. All right. I also want to print it out, so I'm going to print both the pot val and I'm going to print the duty cycle DC, because that'll help me debug if I have some sort of problem. Okay, now what I'm going to do is I'm going to do a sleep for how long? For DT, the delay time, which was a 1/10 of a second. All right, could it really be that easy? I hope so. I ask you, how many mistakes did I make? Are you guys screaming? Do I have a worldwide audience screaming at me right now for all the mistakes you saw that I didn't see? Okay, let's come up here. I do need everyone to hold their breath. Okay, I do need everyone to hold their breath, and we must get the board perfectly straight. And we're going to hold our breath. Boom, look at that. Okay, now what you see is there at the very left, it is sort of jumping between a 0 value and a 1 value, because sometimes when the potentiometer is all the way to the left, it doesn't quite exactly read 0, and so we can kind of understand that that's what's going on. And now what we're going to do is we're going to start turning this up, and this should start getting brighter. So hold your breath. Boom! Look at that. Shazam! Who's the magic man? I'm your magic man. Look at that. Now we're going to go all the way up to 255. Okay, all the way up to 255. And you guys, it kind of blows the camera out so you can't see it perfectly, but in real life, I can see very clearly that that's full brightness. And now as I come down, I see it very smoothly smoothly going back to 0. Okay, going back all the way to 0 there. Okay, guys, man, I hope that worked for you. I think that was a fun little homework, and I think it was a quick little homework, and I'm hoping you guys really enjoyed it. I kind of had fun with that. Now, never fear, I'm going to give you a homework assignment, and the homework assignment for next week is going to take it to the next level. And what I want you to do is I want you next week, instead of using the red LED, I want you to use the RGB LED. Okay, and I want you to have 3 potentiometers, and I want you to mix colors using the three potentiometers. So one potentiometer will set the red strength, the green strength, the blue strength, and you should be able to mix your colors. And you should be able to make that LED any color you want by mixing with the 3 little LEDs. Okay, guys, as always, I want to give a shout out to all of you friends who are helping me out over at Patreon. It is your support and your encouragement that keeps this great content coming. You guys that are not helping out yet, take a look down in the description. There is a link over to my Patreon account. Think about hopping over there and hooking a brother up. Seriously, guys, I'm getting like a lot of expenses associated with my equipment and my gear and my studio and my software and all of that. And so I really appreciate that Patreon help to kind of keep everything operating at peak performance as far as my studio and my gear and my hardware goes. Also, you can help me by giving me a thumbs up. That helps me with the old YouTube juice. If you haven't already, subscribe to the channel. When you subscribe, make sure that you ring that bell so you'll get future notification when the next classes are coming out. And as always, share this video with your friends and family. Share it on social media because the world needs more people doing engineering and coding and fewer people sitting around watching silly cat videos. Paul McWhorter, resist the metaverse from TopTechBoy.com. I will talk to you guys later.